Okay, so this is our 2019 question 2. It's a complex number question, and it says, okay, so it gives us Z1 is 2 plus I. Now, if it didn't give us Z1 there, it has also plotted Z1, so we'd be able to see from looking at our Argand diagram that Z1 is 2 plus I, because that's its point on the Argand diagram. Okay, it then says Z2 equals 2 Z1. Find the value of Z2 and plot and label it on the Argand diagram. Okay, so there we go. Okay, so Z2 is equal to 2 Z1, and I know Z1 is 2 plus I. So here I'm going to say that it's 2 times, and I'm going to fill in what I know Z1 is, so 2 plus I. Okay, and then at this point we can just do this out with our algebra. So I'll have 2 times 2, so I'll get 4, and then 2 times I is 2I, so plus 2I. So when I go to plot that on the Argand diagram, I go to 4 on my real axis. So remember, real things are on the ground, they're the horizontal axis, so 4 on that. And then my imaginary axis, they actually have them labelled here for us, real and imaginary, so that's quite nice. But if they didn't, the imaginary axis is like if stuff's up in the air, up in the sky, or if your head's in the clouds, whatever, it's up here, okay? It's this one that goes up and down. The y-axis, okay, is the imaginary axis on our Argand diagram here. So to get to 2i, I'm going to 2 on the imaginary axis. So this point here is going to be Z2. Okay? Now, it has this Z1 with a line over it. Okay, so Z1 with the line over it, they actually tell us what that is. It's the complex conjugate of Z1. Okay, so write down the value of the complex conjugate and plot and label it on the Argand diagram. So we know that the complex conjugate means you change the sign of the imaginary part. Okay, so the complex conjugate, you change the sign of the imaginary part. Okay, so if you didn't know that, take it down. So up here, Z1 was 2 plus I, so the conjugate of it is 2 minus I. Okay, and then it says investigate if, and then there's lines on both sides of Z2, so the modulus of Z2, so that's the distance from the origin, is equal to the modulus of Z1 plus Z2. Okay, I actually forgot to plot this up here. I need to plot the conjugate of Z1. So it was 2 minus I, so it's down here. So that was my conjugate of Z1. So we're investigating if this plus this is the same distance from the origin as this is here. Okay, so if I was to add this going across, if I was to add that line to get from the origin to Z1, if I was to go and add that distance onto my conjugate, what I'd end up with is at this point here. So what they're asking me is, if I add Z1 and the conjugate of Z1 together, so I end up at this point, is this point the same distance from the origin as this point here, my Z2? Okay, so straight away we can already see it's probably not going to be, but we need to show why. So let's just have a look. Okay, so the first thing we're going to do is show that we know Z1 and the complex conjugate of it is going to be a distance of 4 units away from the origin. So we can add these two together. Okay, so what I have so far is, if we kind of break this down, so I can look at, for half of it, the modulus of Z2, and then I'll just go over here to look at the modulus of Z1 and the conjugate of it. Okay, so this here is the modulus of, and I'm going to fill in Z1 was 2 plus I. So 2 plus I. So I've filled in Z1 there, and then I'll fill in the complex conjugate of Z1 is 2 minus I. So plus 2 minus I. Okay, and we're finding the modulus of these. So we're finding the modulus of, well, we have 2 plus 2, so 4. And I minus I is nothing. So we're finding the modulus of this 4 plus 0I is actually how I should have written it, considering it's going to be on the argand diagram. Okay, so we're finding the modulus of this, which we know is just 4 units. Okay, 4 exact units. So that is equal to 4. Okay, over here then, the one for the modulus of Z2, well, we have a triangle like this. This is just a sketch, and it was 4 units across and 2 units up. Okay, so if we look here to get from this Z2 to the origin, okay, so if we're looking at this to the origin, I'm saying, okay, well, it's that line there. So I'm creating this triangle. Okay, so I'm just going to sketch out that triangle there. So I want to figure out, okay, well, what is that modulus? So we're going to use Pythagoras' theorem. So we can say, just as a reminder of what Pythagoras' theorem is, it's a squared plus b squared is equal to c squared. So here, my modulus is the c squared. Okay, it's the hypotenuse. It's the side opposite the right angle. So always when we're finding the modulus, it's always going to be c squared in Pythagoras' theorem. So that's kind of nice to know. So we can fill this in. So we have the two sides of the right angle triangle. So we have a 4 and we have a 2. Okay, and they're going to be equal to c squared. So the 4 and the 2 are being squared. So I'm going to have 16 plus 4 is equal to c squared. So I have 20 is equal to c squared. Now I don't want c squared, okay? I want just c to figure out my modulus is. Okay, so here I want to just know what c is. So I want to square root this to get rid of the squared. So if I square root that side, I have to square root that side, and I'll be left with the square root of 20 is equal to c. So the square root of 20 is my modulus there for Z2. Okay, so the modulus of Z1 plus the complex conjugate of Z1 is equal to 4. The modulus of Z2 is equal to square root 20. Okay, so the square root 20, it does not equal 4. So my modulus of Z2 does not equal the modulus of Z1 plus its complex conjugate. Okay? Then part B says show that Z1 equals 2 plus I is a solution of this equation. So this is just a quadratic equation. So we can do this two ways. We can either just solve this, okay? So we can just solve this out as if it's a quadratic, and if the z's were x's here. So if we do that, let's see how we get on. So we'd say z squared minus 4z plus 5 equals 0. And then we have to go to the sides. Now, this is where, okay, so we can't solve for complex numbers. We can't solve for imaginary numbers using our usual, where we find things that multiply to give the last number and add to give the middle number. But we can factorize, we can solve through factorizing using my formula minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we can solve for it using that. Okay, so now this is the more difficult way of doing it. So what I might do is just show you guys an easier way and then come back to this if you are interested. So if we think that this is a solution, then everywhere here we have a z, we can fill in what z is equal to here. So my other way of doing this, so I'll just do a big or, is that I have the equation z squared minus 4z plus 5 is equal to 0. And I have that z1, or just z, is equal to 2 plus I. Okay, so everywhere there is a z here, I can fill this in. So I'll have 2 plus I squared minus 4 by 2 plus I plus 5 is equal to 0. Okay, so 2 plus I squared is 2 plus I by 2 plus I. And then I have minus 4 times 2 is 8. And then minus 4 times I is minus 4i. And I have my plus 5 that I'm bringing down from the line above. So here, when I work this out, so I'm going to have 2 times 2 is 4. 2 times plus I is plus 2i. I by 2 is plus 2i. And then I by I is I squared. And then I have minus 8 minus 4i plus 5 that I'm carrying down is equal to 0. Okay, so when we go to simplify this, so my numbers here, so I have a 4 minus 8 plus 5. So when I simplify those, I'll get 1. And then my i's cancel out because I have a plus 2i minus 4i. So they're going to end up giving me plus 0i. And then I have this I squared. Now we know I squared is equal to minus 1. So I'm going to replace I squared here with a minus 1. Okay. So I have replaced I squared there with a minus 1. Because we know that they're equal. And then I'll just carry down this equals 0. So I have 0 equals 0. So that has shown there that this is a solution to this. So that's a nice easy way of doing it out. Okay, now this is a more difficult way. So, but just in case now that I've started it, in case you're interested, we would end up with, so when I fill in this stuff, so I'd have minus b, so minus a minus 4. So I'll get a plus 4. And then I have plus or minus the square root of, so this is if they just told me find the solutions instead of show that this is a solution. Okay, so in this case they said show blah 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 is a solution, so I could just sub it in. But if they didn't give me this and they just said find the solutions, this is what I'd have to do out. So I'd end up with 4 plus or minus b squared, so minus 4 squared is 16. And then I have minus 4 times a, so just times 1. So still minus 4. And then times c is times 5. and that's all over 2 times 1, which is 2. Okay, so under my square root here, this is where we're running into the problem. This is where we spot complex numbers, because they have this imaginary part that we're about to see here. Under my square root here, I have 16 minus 20. Okay, so under my square root, what I'm going to end up having is a number that I can't actually get the square root of. Okay, so I'm going to have a number here in my square root. So I have a plus or minus a square root of minus 4. Okay, so we cannot get the square root of that minus 4. Okay, so I'm just going to split this up into my real parts and what's about to be my imaginary parts. Because we know that when we first started looking at imaginary numbers, remember we said I is the square root of minus 1. So we can take a minus 1 out of square roots. If I have something like, let's say, square root of minus 25. We were saying, okay, well, that's the square root of 25 and then I. We just took out the minus there so that we could say that that was 5I. So we're going to do the exact same thing here. So I'm about to just split it first of all into the real parts and then the imaginary parts. So I'm going to have 4 divided by 2 and my plus or minus my square root minus 4 divided by 2. Okay, so I'm going to have 4 divided by 2 is 2, and then I have plus or minus, and then I have the square root of, I'm going to change minus 4 to just being a 4, and I'll take out the I. Okay, so that's the minus gone. Okay, because I have an I there, and then I have over 2. So I'll have 2 plus or minus, square root of 4 is 2, so I have 2I over 2, so that's going to give me 2 plus or minus 2I divided by 2 is just I. So I have 2 solutions to this here. I have the one that's 2 plus I and the one that's 2 minus I. Okay, because I had 2 plus or minus. So remember when we use this minus b formula at the end here, when we're typing it into our calculator, we need to type it in once with the plus and once with the minus and get our 2 answers out. So those are my 2 answers here. So that's showing that one of my answers that I got out was the 2 plus I there. But that's definitely the more difficult way, I'd say, of the two of them.